We're going to do number 9. What is the first thing that we have to do with this one? Yep, we have to draw a diagram. You two will be split in a minute. Okay, so have a read of the question. Let's see, everybody make an attempt at drawing the diagram. Should have had a decent chance to just read that. And we remember, how do you guys remember your north, east, south, west?
Never eat soggy.
Me too. Never eat soggy Weet-Bix. I had a student one year who said, oh, miss, I remember it by news. I go, that doesn't quite work, news. But anyway, but yeah, I go never eat soggy Weet-Bix. Okay, so cyclist is 32 kilometres east and 18 kilometres south of her starting point. So we can put our starting point here. So she's gone 32 east, then 18 south, and we clearly want to find how far she's going to return to her starting. So pretty simple. You've done your diagram now. If in a test or an assignment it's a worded question and you draw your diagram incorrectly, so you accidentally put the 32 where the hypotenuse was, most of the questions will be out of 4 marks or 3, let's say 3 marks. If your diagram is wrong, then you lose 1 mark. But if your working is correct for your diagram, you will still get 2 out of 3. Yeah? If there is no diagram and it's wrong, well, I can't give you anything. So that's why it's really important that you have a diagram and you label it with X. Yep. For a diagram in a test, yeah, if it's a worded question, absolutely have a diagram, because 1 mark will be for the diagram. Correct. Doesn't tell you, but you must have one. Correct. Okay, now here we go. We're finding the hypotenuse. So we remember Pythag. It's the 2 lengths that make up our right angle. We're going to square them, and that's going to equal our hypotenuse squared. Do we agree? So it's x squared equals 32 squared plus 18 squared. And we don't want x squared, so we have to root it. So therefore, fancy pants, you know the 3 dots mean therefore? Yes. Right, therefore, x is the square root of 32 squared plus 18 squared, and it's all your calculator job from now on. So depending on what calculator you have, like you can see when I've put mine in, it comes up with a funny little thing, but you have I don't know if you have S to D or F to D, but I can just press my F to D, S to D button, and it goes from exact to decimal. There we go. So 36, I'm going to do 2 decimal places. What shall I do? 36.72. And don't do all the hard work and then lose half a mark because you don't put units. So always make sure that you pop units there at this point in time. Okay, part B. Part B, how long would it take her to return to her starting point if she can ride at 36 kilometres per hour? So we've got our speed. Who remembers the connection between speed, distance and time? Yes. Yes. Speed, can you see that? So speed equals distance divided by time. Like, it's common sense. If you're travelling, if you've covered 100 kilometres in 2 hours, then you've been travelling at 100 over 2 hours. So 100 divided by 2 is 50, so 50 kilometres per hour. Okay, so how long would it take? We want the time here. How do I get rid of this divide by t? Is that 2? You can't see that? Yep, to get rid of a divide by t, we times. To get rid of a times s, we divide. So we have here, from the same formula, we have time equals distance over speed. And we also have, can I fit it in? Distance equals speed times time. They're just handy little formulas that we should know, a bit of common sense. So if we want the how long, we're going to use this one. So it's going to be time is our distance, 36 kilometres, divided by our speed, 36.72 kilometres, divided by our speed, which is 36. Yep. Oh, yep, sorry. And while I'm here, right, I've still got that answer in my calculator, so I'm not going to type in 36.72. I'm going to take that answer that I have, which is exact. So notice if I just say now divide, see how the calculator takes the answer? Yours will do that too, right? The scientific ones are just like this. They're both Casios. If you did something else, you can actually call up your answer. You've got a physical answer key. Mine is above the bracket there, the negative. Okay, and I can divide by 36. So 1 hour, so 1.02, shall we say? Yep. 02 hours. And I'm happy with that. Does anyone know how they can change that to how many minutes? So that's right, there's 60 minutes in an hour. So if I say 0.02, I want that percent or that decimal of 60 minutes. So roughly 1 hour, and we'll say 1 minute. Okay, times it by 60, 1.2, so we'll just say 1 minute. You do have a button on your calculator that you press it and it actually converts it, but let's not bother. We'll just go through this one together. I know one person has anyone else done this one? Good-o. All right, so find the height of an equilateral triangle with sides of 10 centimetres. What's one of the key words in this question? Yes? Equilateral. Yeah, absolutely, equilateral. So we draw our equilateral triangle. And what do we know? All sides are equal, so I will put as much information as I can into my diagram. So we know that that's 10, 10, 10. What do we know about these angles? What's the size of those, Micah? Excellent, they all add up to 180, and that means because they're equal, then this is 60 degrees. So Houston, we have a problem. Yeah, why is that? Because Pythagoras' theorem only works for right angle triangle. So where's the right angle? And this is where we have to make it. And that was one of the things that we remembered and I asked you to write down in your books. So if you notice this one here, if we cut, right, we split it right down the middle, then we can see where our right angle is. Does that make sense? So that's what I'm going to do. I'm going to split this down the middle. Some of you don't need to draw another triangle if you don't want to. I'm all about get rid of the white noise. And so by that, I mean I now know that this is 10, this is 5, and what am I wanting to find? The height, yeah, which would be that. Now, I'm tempted to put H for height, but why didn't I? Yeah, and what do you think if I put H there? What might some people who aren't up with Pythagoras say? What do you think H might stand for? No. Hypotenuse. Yeah, so look, if you think I'm all over it, I know that H is the height and it's not the hypotenuse. Go for it. A lot of mathematicians, we use hypotenuse as a capital H, so we don't mix it up. So hypot. Whereas little h generally represents height. So when you sort of think, oh, it doesn't really matter what letters we use, the capitals and the little are actually, So anyway, up to you. I'm sticking with x. So what will be my first line of Pythag? Excellent, x squared. So we're taking the two lengths that make up my right angle, which are x squared plus 5 squared equals 10 squared. I know it's been a whole weekend ago since we did this, but hopefully we know how to get rid of that plus 5 squared.
You have to flip it around.
Yeah, when you say flip it, what does that mean? How do I get, what's the opposite of adding? Taking. Excellent. So we're going to say that's x squared, 10 squared, take 5 squared. And by now, some of you, sorry, is that too small?
No.
Okay, and therefore, oops, it's decided to pause. Oh, for the days when my board comes back. Therefore, x is going to be, we pop that in our calculator, the square root of 10 squared minus 5 squared. And you'll get your answer. Okay, so 8.66. Why do we know that that is a reasonable answer, that we're probably correct, Aidan?
Because it's smaller than the hypotenuse.
Excellent. It's smaller than your hypotenuse. And, you know, 10, 5, 8 seems that we're on track. And let's not forget the centimetres. Oui, oui?
Oui, oui.
Okay. Hands down for a moment, please. And you might go, oh my God, it's question 15 again. I really loved, Jordan was talking to me before and he goes, I did it a different way. And I prefer the way that he looked at it. Right? So, you don't mind if I say, do you, Jordan?
No.
Okay. So, he's looked at, if I have done the diagonals going across like so, one of the things that we knew from our properties, because he's done this and he's made it easier, I think, from the square, that the diagonals intersect at 90 degrees. Yeah? So when he's now looking at this, he can say, that's a 90 degree there. And then that would be what length? What's this length right here?
30.
Yeah. So he's now got, very clever. He's got 30, 30, and then x. So he doesn't have to deal with the whole 1x squared plus another x squared. Really straightforward. So fantastic. And that's going to show you that there's more than one way sometimes to do a problem. And don't say, oh, well, I didn't do it the same way that the teacher did it. Please go back. One of the reasons that I wanted to remind you about this was that we did a question like this right at the beginning of the year, and I wanted you to go back and look at your notes to try and remind yourself and to show you that having a well-organized book is really helpful. Okay, now what I would like you to do is grab your calculators, please, and your worksheet, your assignment. Questions A, B, C, and D are reasonably straightforward, and another reason why I sort of wanted to remind you about this for question 15 is it's pretty similar again, yeah? E should also be similar if you can use your calculator correctly. So what I'm going to ask everybody to now do is, can we just check on our calculator what is, well, we might as well do it from here. Hey, where'd it go? Let's try and work out what is 62 and 2/7 squared. So 62, I'll get rid of that. Oh, I made it right. 62 and 2/7 squared. So can you do that on your calculator, and let's see what answer you get. Right. Okay, so boys, can you just stop and listen for a minute? All right, so the issue is, how do we put in a mixed fraction? Can you look really carefully at your calculator, and I want you to try and find this button. Okay, so on mine, and yours will be the same, you can see that it's just above your normal fraction button. But because it's in yellow, we actually have to push shift. So put brackets first. We're going to go bracket and then shift fraction. And now I can pop in the 2 and the 7th. What's happened in the past is some students have put a fraction, just a normal fraction, and then popped the 62 in front. And you'd get the wrong answer, because if you just tried going fraction button, 2/7, and then you put 62 in front there, your calculator will actually say 62 times 2/7, and that's not what this should be. It's 62 plus 2/7, okay? So let's see, what do we get? I go enter. Yep, I get that. If I now press my decimal, oops, I didn't square it. So I'm looking at that and I'm going, that's crazy. I didn't square it. So I can use my arrow keys to go backwards, press my squared, and now, better, because it should be,
Oh, we've got the same out. How do you make it decimal?
right?
Oh my god, I've got the same number.
So
Oh.
your decimal, you've got either an F to D or an S to D, and if you keep pressing that, it goes back and forth.
Which one?
S to D or F to D. So with F, the extension there, I just want to give you a hint here or ask you a little bit of a question, and that is there a difference between 3x squared and 3x all squared? Absolutely, because 3x squared, that is just 3, oh dear, 3 times x, do you agree?
Yeah.
Whereas 3x squared will be 3 times x times 3 times x. So this one gives me 9x squared, whereas this one is 3x squared. So why am I asking you this? Well, with this, are you wanting to square the whole 4x? Really? I thought the side said it's the whole length squared. So for this one, you need to have the 4x squared in a bracket. Okay? So for that question, you should be looking at 4x squared. So there's your hint there. For the rest of it, all right, soccer field, I think you've done a similar question. We just did, Carolyn, it was a shed that was so many meters by so many meters. Well, this is now a soccer field, same bizzo. It's still a rectangle. All I've done is change the theme and change the numbers. And that's the only thing that I've got up my sleeve, right? For a test, I would try and find some other rectangular shape. Maybe it's somebody's room instead of a shed or a soccer field. Okay? You might want to write some of this down. Question 4, my tip to you, converse of Pythagoras' theorem. So how do you prove that something is a right angle? How do we prove it? If it fits Pythag, then it's going to be right angle. If it doesn't fit Pythag, it's not right angle. Okay? So little things like that. What I will ask you to do then is have a go. You can start now. So we've got 15, 18 minutes. I will see you again on tomorrow. Okay? So you've got homework tonight. You've got a little bit more of this lesson to try and work on your assignment. You will have time on Tuesday's lesson not to work on your assignment, but to go, oh, I'm stuck on this, and whatever, couldn't do. And then I would expect that you hand it up to me on Thursday.
Yep.
This week. Yep.
Yep.
Yep. So, some of the tactics that you should be doing. Not have any notes for the test, no.